Welcome to Physics with Amol sir. So this is video for class 9 and we are going to continue with the chapter motion. Okay. So in the previous video we saw what is meant by motion. We saw four very important concepts that were distance, displacement, speed and velocity. I hope all of you have seen those topics. Now we are going to continue with the next topic. So we have understood the meaning of motion, the change in position of an object with time. That we mean by motion. So today we are going to see about uniform motion and non-uniform motion, and we will talk about concept of acceleration, and we will talk about some numericals, some basic numericals that are asked on the chapter. Okay, so let us begin. First concept of uniform motion. So what we mean by uniform motion? First, this is the definition. If an object covers equal distance in equal intervals of time, the object is said to be in uniform motion. What is the meaning? Let us say a car is going on a highway. Okay, it covers 10 meters, and to cover 10 meters it is taking 5 seconds, for example. For the next 10 meters again it takes 5 seconds. Fine. So for the same interval of time it is going to cover the same distance. If it is doing that, we say the car is in uniform motion. Okay. Or another way to look at it is, if an object is moving with a constant speed. Okay. So if an object moves with a constant speed, we say the object is having a uniform motion. This is concept of uniform motion. So what is non-uniform motion? Obviously you will say, if object is moving with speed that is changing. If the speed is not constant, we can say the object is having non-uniform motion. Okay, very easy concept. Uniform motion means if object is moving with constant speed. Okay, non-uniform motion means if the speed is not constant, the speed is changing, that motion is called as non-uniform motion. Non-uniform motion, we give another name and we call it as accelerated motion. So non-uniform motion is also known as the accelerated motion. Okay. So I hope these two things are clear. Now we define a quantity that is called as acceleration. First, this is the definition. Acceleration is defined as the rate of change of velocity. Once again, what is acceleration? Acceleration is defined as rate of change of velocity. This is the formula. A is equal to V minus U upon T. Now you will ask, what is the meaning of all these? Let us see one by one. A stands for acceleration, V stands for the final velocity, U stands for initial velocity, T stands for time, and this is the formula. A is equal to V minus U by T. Okay, now what is the meaning of all these things? So imagine an object, a car is moving, suppose. Okay. Initially the car is moving at a speed of, let us say, 20 meter per second. Okay. Then what happens after some time? The driver decides to increase the speed. So from 20 meter per second, slowly the speed increases and it becomes 50 meter per seconds. Getting the idea? So first what was the speed? First the speed was 20 meter per second. Then it has become 50 meter per second. To have this change of speed, some time was required. Let us say he took a time of 10 seconds to change this speed. Okay. So to change the speed from 20 meter per second to 50 meter per second, the time taken was 10 seconds. Now we can find the acceleration. How will we find? We say A is equal to V minus U by T. V is the final velocity. How much was our final velocity? 50. So 50 minus U. U is the initial velocity. How much was initial? 20. So 50 minus 20. This gives a change in velocity. 50 meter per second minus 20 meter per second. So how much velocity change? 30. 30. Okay. So 30 meter per second is the change in velocity. So V minus U upon T. How much was the time? Time was 10 seconds. So 30 divided by 10. Answer becomes 3. Correct? So this is the acceleration. Our velocity is changing by 3 meter per second in 1 second. Okay, and so we say SI unit of acceleration is meter per second square. Remember, SI unit of acceleration is meter per second square. Okay, and this is the formula. So what acceleration gives? Acceleration tells you with what rate your velocity is changing, how fast our velocity is changing. That quantity we call as acceleration. So I think you must be knowing, in our vehicles we have something called as the accelerator. You know this, right? So what does the accelerator do? Accelerator is used for changing the speed of your vehicle. If you move the accelerator, either vehicle will start moving fast, or if you move it, the vehicle becomes slow. Correct? So accelerator is used for changing the velocity. Correct? And the word derives from acceleration. Okay? So once again, acceleration, a very important, a very basic concept. Fine? Now, acceleration can be of 3 types. Which are the 3 types? Imagine, like we had the first case, our velocity was 20 meter per second, then it became 50 meter per second. Then if you go on increasing, it might become 70 meter, 100 meter per second. Correct? The velocity can go on changing in this case. So, if the velocity goes on increasing with time, we say the acceleration is positive. Getting the idea? If velocity is increasing, the acceleration is positive. But then what we can do, let us say a car is going at a certain speed and the driver applies the brakes. If the brakes are applied, the velocity will start to decrease. If the velocity is decreasing, we say acceleration is negative. Okay? So, if velocity is decreasing, acceleration is called as negative. Correct? Or the other name we give for it is retardation. Okay? Or deceleration. So, either you call it negative acceleration, or you call it retardation, or you call it as deceleration. Okay? And the third type is called as zero acceleration. What is meant by zero acceleration? If an object is moving with uniform velocity, means constant velocity. So, if the object is moving with uniform velocity, final velocity and initial velocity will be the same. So, V minus U will become 0, thereby acceleration will also be 0. Okay, so zero acceleration means if object is moving with a constant velocity. Fine. So once again, positive acceleration if the velocity is increasing with time. Second one, negative acceleration if velocity is decreasing with time. Zero acceleration if the velocity is constant or the velocity is 0. For zero acceleration, we can get 2 cases. Either the object is moving with constant velocity or it is not moving at all. It is at rest. The velocity is 0. Correct? So this is the concept of acceleration. Next, we will see a very simple numerical. Correct? So we are going to go to the numericals in our textbook. So you should be seeing example number 8.1. An object travels 16 meter in 4 seconds and another 16 meter in 2 seconds. What is average speed of the object? Okay, so what is the case? So there is an object which goes for 4 seconds, it covers 16 meters. In the next 2 seconds, it is again covering 16 meters. We have to find the average speed. How do we find average speed? First, we find the total distance. Correct? So first, how much we traveled? 16 meter. After that, again 16 meter. So total distance is 16 plus 16, 32 meter. How much was the time taken to do this? First we travelled for 4 seconds, next for 2 seconds. So total time was 4 plus 2, 6 seconds. Therefore, the average speed. Average speed, how do we find? Average speed is total distance by total time. Correct? So we'll get 32 upon 6. That will give us the average speed, which is 5.33 meter per second. Getting the idea? So this is how we find the average speed of an object. Now let us see one more. This is example 8.2. The odometer of a car reads 2000 kilometers at the start of a trip and 2400 at the end of the trip. If the trip took 8 hours, calculate average speed of the car in kilometer per hour and meter per second. So as you can see, when we want to find out the average speed, we have to see the total distance traveled. So how much is the total distance traveled? We have to see our odometer. So I think I already told you, odometer means it is a meter which gives the total distance traveled in our vehicle. So the final reading was 2400. Initial reading was 2000. So total distance will be 2400 minus 2000, which is 400 kilometers. Fine. How much is the time taken? Time taken is 8 hours. The total time taken is 8 hours. Now, how do we find the average speed? The total distance by total time. So how much was the total distance? 400 kilometers. How much was the time? 8 hours. So we'll find velocity, the average velocity or average speed as 400 by 8, which is 50 km per hour. Okay. This is how we calculate numericals for average speed. Okay.